Reflow soldering process. Reflow soldering is a process in which a solder paste, a sticky mixture of powdered solder and flux, is used to temporarily attach one or several electrical components to their contact pads, after which the entire assembly is subjected to controlled heat, which melts the solder, permanently connecting the joint. Heating may be accomplished by passing the assembly through a reflow oven or under an infrared lamp, or by soldering individual joints with a hot air pencil. Reflow soldering is the most common method of attaching surface mount components to a circuit board, although it can also be used for through-hole components by filling the holes with solder paste and inserting the component leads through the paste. Because wave soldering can be simpler and cheaper, reflow is not generally used on pure through-hole boards. When used on boards containing a mix of SMT and that components, through-hole reflow allows the wave soldering step to be eliminated from the assembly process, potentially reducing assembly costs. The goal of the reflow process is to melt the solder and heat the adjoining surfaces, without overheating and damaging the electrical components. In the conventional reflow soldering process, there are usually 4 stages, called zones, each having a distinct thermal profile: preheat, thermal soak, often shortened to just soak, reflow, and cooling. Preheat zone. Preheat is the first stage of the reflow process. During this reflow phase, the entire board assembly climbs towards a target soak or dwell temperature. The main goal of the preheat phase is to get the entire assembly safely and consistently to a soak or pre-reflow temperature. Preheat is also an opportunity for volatile solvents in the solder paste to outgas. For paste solvents to be properly expelled and the assembly to safely reach pre-reflow temperatures, the PCB must be heated in a consistent, linear manner. An important metric for the first phase of the reflow process is the temperature slope rate, or rise vs time. This is often measured in degrees Celsius per second, C/S. Many variables factor into a manufacturer's target slope rate. These include target processing time, solder paste volatility, and component considerations. It is important to account for all these process variables, but in most cases sensitive component considerations are paramount. Many components will crack if their temperature is changed too quickly. The maximum rate of thermal change that the most sensitive components can withstand becomes the maximum allowable slope. However, if thermally sensitive components are not in use and maximizing throughput is of great concern, aggressive slope rates may be tailored to improve processing time. For this reason, many manufacturers push these slope rates up to the maximum common allowable rate of 3 degrees Celsius per second. Conversely, if a solder paste containing particularly strong solvents is being used, heating the assembly too fast can easily create an out-of-control process. As the volatile solvents outgas, they may splatter solder off the pads and onto the board. Solder balling is the main concern of violent outgassing during the preheat phase. Once a board has been ramped up to temperature in the preheat phase, it is time to enter the soak or pre-reflow phase. Thermal soak zone. The second section, thermal soak, is typically a 60 to 120 second exposure for removal of solder paste volatiles and activation of the fluxes, where the flux components begin oxide reduction on component leads and pads. Too high a temperature can lead to solder spattering or balling, as well as oxidation of the paste, the attachment pads and the component terminations. Similarly, fluxes may not fully activate if the temperature is too low. At the end of the soak zone, a thermal equilibrium of the entire assembly is desired just before the reflow zone. A soak profile is suggested to decrease any delta T between components of varying sizes, or if the PCB assembly is very large. A soak profile is also recommended to diminish voiding in area array type packages. Reflow zone. The third section, the reflow zone, is also referred to as the time above reflow or time above liquidus, TAL, and is the part of the process where the maximum temperature is reached. An important consideration is peak temperature, which is the maximum allowable temperature of the entire process. A common peak temperature is 20-40 degrees C above liquidus. This limit is determined by the component on the assembly with the lowest tolerance for high temperatures, the component most susceptible to thermal damage. A standard guideline is to subtract 5 degrees Celsius from the maximum temperature that the most vulnerable component can sustain to arrive at the maximum temperature for process. It is important to monitor the process temperature to keep it from exceeding this limit. Additionally, high temperatures, beyond 260 degrees Celsius, may cause damage to the internal dies of SMT components as well as foster intermetallic growth. Conversely, a temperature that isn't hot enough may prevent the paste from reflowing adequately. Time above liquid ooze, TAL, or time above reflow, measures how long the solder is a liquid. The flux reduces surface tension at the juncture of the metals to accomplish metallurgical bonding, allowing the individual solder powder spheres to combine. If the profile time exceeds the manufacturer's specification, the result may be premature flux activation or consumption, effectively drying the paste before formation of the solder joint. An insufficient time/temperature relationship causes a decrease in the flux's cleaning action, resulting in poor wetting, inadequate removal of the solvent and flux, and possibly defective solder joints. Experts usually recommend the shortest TAL possible. However, most pastes specify a minimum TAL of 30 seconds, although there appears to be no clear reason for that specific time. One possibility is that there are places on the PCB that are not measured during profiling, and therefore, setting the minimum allowable time to 30 seconds reduces the chances of an unmeasured area not reflowing. A high minimum reflow time also provides a margin of safety against oven temperature changes. The wetting time ideally stays below 60 seconds above liquid ooze. Additional time above liquid ooze may cause excessive intermetallic growth, which can lead to joint brittleness. The board and components may also be damaged at extended times over liquid ooze, and most components have a well-defined time limit for how long they may be exposed to temperatures over a given maximum. Too little time above liquid ooze may trap solvents and flux and create the potential for cold or dull joints as well as solder voids. Cooling zone. The last zone is a cooling zone to gradually cool the processed board and solidify the solder joints. Proper cooling inhibits excess intermetallic formation or thermal shock to the components. Typical temperatures in the cooling zone range from 30 to 100 degrees Celsius. A fast cooling rate is chosen to create a fine-grained structure that is most mechanically sound. Unlike the maximum ramp-up rate, the ramp-down rate is often ignored. It may be that the ramp rate is less critical above certain temperatures. However, the maximum allowable slope for any component should apply whether the component is heating up or cooling down. A cooling rate of 4 degrees Celsius per second is commonly suggested. It is a parameter to consider when analyzing process results. Reflow soldering process simulation. Preheat zone. Thermal soak zone. Reflow Zone. Cooling Zone. Reflow soldering process with soldering oven. Close view of reflow soldering process. Another example.